will be available on YouTube. I'll also be sending you a link through Teams, so if you want to watch it, but then we will go ahead and save this onto YouTube as well. I want to thank Niraj for presenting today. He is a repeat presenter. He presented back in 2018. And today's presentation, Open Architecture Necessary but Not Sufficient to Achieve MOSA Objectives. In this talk, we will present CMOS mounted form factor material solutions to facilitate convergence of warfighting capabilities. We'll discuss the CMOS SOSA system that facilitates integration of new capabilities with a lower non-recurring engineering costs and faster capability delivery. We will describe the consolidation of disparate models into a common ruggedized chassis to achieve and sensor to shooter capabilities. Niraj Srinivastav is currently serving as GM and Vice President for Pacific Defense, which specializes in non-kinetic warfare defense technologies. His responsibilities include leading technology development with an emphasis on multi-domain battle management and C2 products for CMOS and SOSA compliant systems with embedded artificial intelligence. Prior to that, Niraj served as the product line manager for multi-domain battle management with electromagnetic warfare systems missions in space and airborne systems at Raytheon Company. As a product line manager, his responsibilities were to manage a $35 million product line focused on cyber and electronic warfare planning and management solutions that included command and control in constrained environments as well as spectrum management. His programs include EWPMT, Ravenclaw/Feather, and I2WD cyber exploitation. Niraj has over 25 years of management systems, architecture, and engineering domain expertise in cyber operations, multifunctional RF systems, in supercomputing, distributed computing architecture, and modeling and simulation, imaging and signal processing, and remote sensing. Prior to joining Raytheon, Niraj worked at Microsoft, HP, Compaq, and numerous startups. Niraj has demonstrated his expertise in complex technical systems as senior technologist, change agent, and thought leader in transforming emerging technologies from the R&D environment through initial development and production. Niraj holds a PhD in theoretical physics from the University of Rhode Island and has over 24 publications and patents to his name. I'd like to ask you to, if you have questions throughout the presentation, you can put them in chat and we'll make sure that we address them at the end. And with that, I'd like to hand over the presentation to Niraj, and thank you again for being willing to present for a second time to the Association of Old Pros.
Thank you, Mary. Hopefully everybody can see my charts and hear me.
We see your charts and we hear you well.
Thank you. Thanks for that introduction, kind words. I almost didn't recognize myself when you were describing me. So this is talking about the talk will kind of start out why we need MOSA and what does that mean, and for MOSA to succeed, what are the necessary conditions, and then I will present an argument that CMOS SOSA standards are already here that can actually support Army's goal of producing systems that are based on MOSA principles. And as Mary said, please ask questions. I mean, I'd like to be interactive, even though we are all in a different place in different time zones, but as interactive as possible would be good. There we go. So I have to do a quick advertisement for who we are, where I work, what I do for my day job, besides the introduction that Mary already gave. So I'm with a startup called, the name of the company is Pacific Defense. We were launched last January, right as COVID lockdown happened. So that's been an interesting year to launch a new company during COVID lockdown. We are focused on the non-kinetic fight, comms, EW, cyber, ISR, connecting command and control for the tactical edge. The key thing to remember for our company is what we are trying to do is to leverage standards and bring commoditization for an open architecture RF system and digital product. We are focused on creating a company that can work with the same kind of a mentality that we see in the Silicon Valley mentality, which is focused on the agile development and producing capabilities that leverage what's there in the marketplace. I mean, if you look at how Silicon Valley, the companies work, I mean, they are leveraging open standards left and right. I mean, they have driven the open standards, open system OSS revolution. Really, the proliferation of GitHub is driven by Silicon Valley. So that's the mentality we are bringing, and the idea is to start creating a system where you can actually, if we talk about having system with App Store, but actually creating system, and I'll give you some example how using CMOS SOSA standards, we are actually demonstrating an App Store-like capability for our tactical edge devices. So when Pacific Defense was formed, we started with acquiring a couple of other companies. So we started out with Spectranetics, which has a history, founded in 2011 in Sunnyvale and Mukilteo, Washington. They, I would say, are a leader in the CMOS technology, the part of the open group SOSA technical standards working group, and they've been working side by side with the C5ISR community in developing CMOS technology and CMOS standards and delivering multiple hardware components from chassis to cards, and I'll talk a little more about that. We also acquired a Perceptronic solution, which is a pure AI/ML play. They develop actual algorithms. They do a lot of DARPA and cyber type work. They continue to do cyber work. They're not fully owned by Pacific Defense, but we do have a relationship with Perceptronic. And the idea was that not to insert AI/ML into the system as an afterthought, but to start developing system and do system design that is based on CMOS and SOSA standards, but has machine learning AI capabilities embedded in there to support autonomy, COA generation, and signal processing. Those kind of capability is built into as we design systems from day one. And then recently, at the end of last year, we also acquired Sphere Research. They developed a lot of the actual application, EW SIGINT, radar communication applications, techniques situated in Nashua, New Hampshire. So that actually allows us to bring in some techniques on top of the hardware and integrate that with the AI/ML work that the Perceptronic solution is doing. I won't spend too much time, but as a Pacific Defense, I mean, there are multiple programs and portfolio we are involved in. We are doing work with electronic warfare system, tactical comm, strategic comm, battle management C2 system. That's my area that I manage. As I said, we are also with Perceptronic do a lot of work with applied AI/ML, from training to simulation to human-centric UI capability, multi-domain data fusion, and then we have programs with special programs like SOCOM or other capabilities that we won't get into here. So up front, now that the advertising is over, get into the thesis of our presentation. So I want, I'm going to repeat this over and over, but the 3 points I want to make is modular open system architecture, or MOSA. A lot of RFPs coming out, they ask for the solution should be MOSA based, but I mean, to me that's a principle. I mean, that it should be open system architecture. So that is definitely required for all programs. I mean, we should be requiring MOSA on all programs. But just saying MOSA is usually not enough. I mean, you need to have MOSA. For MOSA to succeed, it needs to be based on standard, like there's a host of standards, CMOS, host, SOSA, FACE, OMS, SPEED, OCA. Just saying open is not enough. Standard at all level of the system modules need to be designed into the system, such that the system can evolve, where every modules in the system can evolve independently. So that definitely is a good thing in terms of innovation and agility of the system, keeping up, facing the threat as we talk about. The other thing it does is it actually creates a robust competitive industrial base around modules that allows you to support innovation, cost reduction, and you need that competition at all phases of the program. So that's the second thing I want you to take away from that. And then I'm not just going to make a theoretical argument that this is what should happen. I will show you that when we started the company Pacific Defense, we started with those principles day one, and we'll give you a case in point and what we have been able to do following those principles. I mean, I'm doing demonstrations and technology development at a pace that's probably 10x of what I used to do in my previous life, and probably the kind of time is related to $2 at the 1/10 the cost. So this journey, I mean, personally for me, I mean, it just didn't start last year at Pacific Defense. I mean, I actually authored a study that was funded by Naval Postgraduate School back in 2014, and the name of the study was Strategies for Competition Beyond Open Architecture. And the link is there. You can read it for yourself. It's 50-60 pages, so I'm not going to bore you about the whole study. But the key finding was that system engineering practices that, at least things are changing very fast, but I mean, still not 100% has changed. I still keep running into system engineers, and we keep having arguments about this. Have become pretty stagnant. I mean, they were designed to perform tasks accurately, predictably, and repeatedly. Not saying that we shouldn't be doing that. We need to be doing that. Plus, we need to continue to have the system engineering models that can continuously modify their behavior in reaction to the dynamic environment we live in. So if you look at the top left-hand side of the picture, I mean, most of us have seen this thing, the rate of technology change, connectivity, complexity, threat, vulnerability, the cost growth is growing exponentially. I mean, these are what we call exponential growth. But most of the history of our humanity, we have lived in this part of the curve, of the exponential curve. These parts of the curves can be approximated linearly, right? So we have developed all our methodology to live in this linear world. Accurate, predictable, repeatable. I mean, you can draw a straight line here. But now, when you try to draw a straight line, it's very hard to draw a straight line in the knee of the curve, because things are changing.
Hey George, how's it going? Hey George, how's it going?
Somebody needs to mute.
This morning, about maybe 10:30.
Nancy, can you mute?
Sorry.
Thanks. Sorry about that.
Thank you. So what we need new ways of doing things that can actually work in this new reality. The acquisition model, system engineering model, how we work needs to change to work in this nonlinear world we live in. And we all know we are living in this world because we all talk about things are changing so fast. Well, the things are changing so fast because we've started living in this part of the world, right? So the new reality requires that we come up with a new way of doing it. And the thesis of of my paper was that you need to be able to create communities of interest, form these networks that's shown in the upper right-hand corners around technologies, are what I call platforms. And then that creates product families around these platforms. And what we need is is at least the data rights needs to be owned openly. If it's open standards, and that doesn't have an issue. But if it's not an open standard, then the government needs to have that data right across those technologies, and then let communities of interest evolve and mature and create competition around the modules. So you have diversity and competition around the software and hardware that are based on some standards. And I'll talk about how this model actually works really well with what CMOS SOSA community is already doing. So one of the most successful example in history is that what we call internet today, based on open market. So if you look at IPv4, that's a standard. That standard allowed this explosion of internet, and that produces other standards like TCP, UDP, and that it creates an explosion of other companies. And now you have software providers that use IPv6, and you have hardware providers that support that infrastructure, and you have this large marketplace that's built around this one standard called the IPv4, now IPv6, but the initiation was through this IPv4 standard. So the point here is that open architecture with standards have the power to produce, the takeaway here is diverse, innovation-driven marketplace that is robust against node failure. So if any one node fails in this network, it does not take away the marketplace. So you're not relying on one big vendor. I mean, the marketplace keeps moving forward. I mean, if you look at the internet market, the mean time of being in the S&P 500 has dropped from 60 years, 70 years to less than 25 years on S&P 500, and that's mostly because if the companies can't evolve and keep up with these nonlinear changes and keep innovating, the market just drops them and they go to somebody else. The success depends on the community evolving and keeping up with the changing world. So instead of artificially trying to change things, the emergent behavior of the community is to adapt to the changing world fairly automatically, right? So that's another key benefit of having this kind of technologies that are based on open standards. So that's the premise of the rest of the talk. That's the theoretical background, the key foundation of what the rest of the talk is all about. Simple example of what I just talked about, and this happened. At least I can't see everybody. So if we were face to face, I can tell how many people lived through this revolution and how many people have not. I have lived through this thing. I mean, I remember having some of these kind of phones. I was never had enough money to own one of these, the bricks, but I've had these kind of phones. But in about 3 years, we went from this kind of a proprietary-based phones where if I wanted some special thing, or if I had an idea about how a particular application should work, I had to go talk to BlackBerry and say, hey, I want to sell you this idea of how a software should work. And then BlackBerry would decide if they wanted to put it on their phone or not. But then Android and Apple came around and they opened up this entire development environment, and it created a marketplace and a large community of developers that allowed them to connect the end users with the developers, and they just basically provided the platform for that interaction. And that model, as you can see in the graph, in about 3 years, they basically displaced this entire market that was based on Symbian and BlackBerry and Windows, and now those other systems don't even exist. It's dominated by these two companies that provide the platform, and then there's an entire industry that they allow to connect to the end user. So now you have a end user needs that are met very quickly because you have this large community that's providing the innovation. So that's the emergent behavior I was talking about. That standards allowed to happen in the mobile phone industry, and that's where the whole concept of the app store came in, right? Because now you have that capability where you have developed this large community of developers that are satisfying the needs of ever changing needs of the end user. So the good news is, since 2014, that study had done, a lot of things have changed. The DoD as a whole, and the congressional mandates are starting to come together. 2021, the National Defense Authorization Act recommends Department of Defense standardized procurement of modular car software according to CMOS SOSA standards. Tri-State Services Acquisition Memorandum from 2019 talks about SOSA, OMS, OSI phase victory standards as vital to our success. The study was called Modular Open System Approaches for Our Weapon System as a Warfighting Imperative. The Defense Acquisition Guidebook is now talking about user standard interface specification. It enables the modular and open system approach. So the idea of MOSA being based on the standards is starting to catch on. And the rest of the talk is to talk about some of the standards that have emerged that can make this the proposition a reality. And they're actually already. What I will do, I want to make a point here is it's already becoming a reality, and this talk is about. I like to say it's an emerging success story for DoD. So, I mean, there is no one standard that to rule them all. There are multiple standards, and the reason there are multiple standards is, and people always talk about, it's like, oh, come on, it's like these. We have tried standards before; they never work. They're always stale. That by the time I want to develop something, the standard doesn't have the capability. But things are changing. I mean, there are multiple standards, but they do interoperate. There are ways to do interoperability. I have a simple example of one study that we did internally. So we looked at the OCS architecture for comms, and if you look at the red thing is mapping from the OCS to the CMOS SOSA standard. So there's a pretty much one-to-one correspondence between what OCS architecture talks about comms and what CMOS SOSA is doing. It's at the most what you need is some kind of a refactoring capability or a gateway to go from one system to another. Right? But you're going to have a set of standards, because what you need if you really want to truly a marketplace that's based on standards, you need a standard interfaces between all layers, all the way from to making the entire ecosystem work, to services, the applications that run on the services, like an application framework like FACE, hosting environment, the platforms, manned autonomous, based on things like CMOS, the hierarchy of sensors, the hierarchy of CMOS sensors, integrated CPU, radio, and security units, how we do security. I mean, we'll talk more about that. What kind of communication infrastructure. Between every layer, the interaction between layers has to be based on standard interfaces for a full system to leverage that ecosystem, and then be able to change any one of these layers, or any one of these services, or any one of these sensors, or even a computation communication model. You can swap things out, swap things in, have that plug and play capability that we see in a lot of the IT industry and the commercial industry today. The whole revolution in cloud space is driven by it being able to do something like this. Mary, I mean, I'm not keeping an eye on the chat. So if you see any questions pop up, please speak up.
No questions yet, but I will let you know.
Thanks. So, and I feel a little overwhelmed to trying to do the SOSA CMOS presentation, because I see some people who are expert on this system. I'm sure they will correct me if I say something wrong. So the idea is, if you look at the sensor open system architecture framework, what it does is it really is a standard of standards. So it takes a host standard and phase standard to create a hardware software interface, and the CMOS standard to create that infrastructure, and then has the application framework, how we run the application on the sensor. So it's a combination of this SOSA sensor management architecture that has system management, task manager, how they behave, the behavior and interaction. It has how does the applications running on the sensor interact with the transceiver, which is defined by the MORA ML2, the modular open RF architecture. And then it has a definitions of a bunch of different software modules that allow you how you process the MORA or the digital RF stream that's coming out, or IQ stream that's coming over the data plane, how you process that, and how you do the command and control of that system using the control plane. So it defines a network that has control plane and the data plane, and how you do cabling. So that's defined by the standard. And then the cards itself that go into the sensor itself, that defines the backplane, it defines the card which are based on the OpenVPX system, the VITA standards. But the key thing with OpenVPX is the issue has been in the past is how the pins connect to the backplane. That's not that's open to the implementer. So that what that does, it makes it very hard to take one VPX card out and put another card in and expect everything will work exactly the same. One other thing what CMOS did was, for every payload card, they have actually defined what the pin out looks like. And what that allows you is that you can take a PNT card from vendor A and plug in a PNT card from vendor B into a chassis that's designed by vendor C. And that's something that has been demonstrated by the government. And if you follow things like MODEX and Pentax exercises, those are some of the things that is being demonstrated quite easily these days.
Niraj, we have a question from Dave Lockhart. His question relates to form factor. Is anyone developing or considering developing a standard for form factors smaller than 3U? This question relates to CMOS.
Yeah, so SOSA organization is looking at a form factor, small VPX and VNX form factor for the make that recommendation to the CMOS Technology Consortium, are developing that as a SOSA standard. That's the one. That's the one I'm aware of. There are probably other standard, but VNX is a small form factor that looks very, personally, it looks very promising and interesting.
Thanks for the answer.
I see Jason is on, but Jason can probably speak to that for a whole hour. You can probably on that subject.
Well, it sounds like Jason may have to be our October person then. So
in terms of so this is 3. So CMOS is 3U VPX standard. And the way you do, so this is just an example. So already today, there are chassis that exist from 14 to 13 that I'm aware of. I think there are bigger ones too. We have plans to do one bigger one ourselves. I don't know of a particular vendor that's doing a bigger one. They probably are. You will see the size of the CMOS community. It's pretty large. So keeping track of all my competitors, what they're doing is a daunting task. but there are communication modules, SDR modules, processing modules, networking modules, PNT modules that exist for these chassis, and you can create systems by basically Lego-like environment by plug and play. That's standard based, and how it connects to the system. Now you can connect to the system platform itself through Victory or OMS. Those things are all well defined now. Software wise, the SOSA also uses that software architecture that I talked about, and what we have done when we started the company, what we had to do add software to what Spectranetics was doing. So even though SOSA sensor management software is not fully developed yet, but they had already published the architecture in their Snapshot 3. All the interaction between all the different SOSA modules haven't been completely defined yet, but the architecture was there. So we leaned forward. We started building our software using the SOSA architecture, not even leveraging all the messaging that's coming soon, but just the architecture itself. And we were very quickly able to take the CMOS capabilities that Spectranetic had and create a layer of software. We call it Charybdis. That's our brand name for SOSA aligned modules like services, task manager, then creating a 3X like service that allows you to integrate things like Red Hawk, TOA, the new radio, feed Photon with Vita like digital RF as a service that takes the MORA and just turns it into a Vita services that allows any application that rely on the Vita services to just plug in. And we were able to very quickly plug in things like Black Horse and Photon and 3DB Labs, a SIGINT application, working with G3E on their common type of capability. But integration of these things, we've been around a little over a year, but to be able to do all these kind of integration in that time, I couldn't have imagined doing that before we actually did this experiment. My CEO at one time, I think when we did the Red Hawk integration, that was like 3 weeks, and he had actually challenged me that there's no way you can do that in less than a year, and we did that in 3 weeks. And what he didn't realize is that he had already paid for all this framework, and it was just, the idea was to plug in a new capability in that framework. I didn't tell him that he had already paid for the framework. But and then you can get, it's really easy to get performance if you're based on standard. The standard is deriving things. So here is an example of a MORA to Vita stream performance. So the blue is the MORA sample weight that we are tuning the radio to, and the orange is a Photon benchmark that's showing how many million samples per second is processing. So we had the Photon connected to our MORA SDR on a 1 gig backplane. In this case, we are in the process of doing an experiment on 10 and 40, and to see scaling at the different networks. But in this case, the Photon benchmark was keeping up with what the MORA was doing, and we kind of saturated out at 30 million samples per second. Around 30 million samples per second. And so if you do the math, that's about the 95% of the bandwidth that 1 gigabit backplane can support. So the adoption of the CMOS SOSA aligned modules has allowed us to develop the CMFF system demos in less than 2 months from planning to execution. And I'll talk a little bit more about that. So one of the things we've been doing, because we have this capability now, we have been doing it like a capability, the CMOS enabled, SOSA enabled capability demonstration every quarter, and every quarter we show something new and what we have added, and that is mostly just taking the stuff that is being done on different programs, integrating that into a mission scenario that we can actually demonstrate that makes sense to the DoD community. But to be able to do that demonstration, it usually takes us less than 2 months from planning. Most of the time goes into planning, and what modules we're going to integrate this time that actually supports a scenario we want to demonstrate. But in 2 months, we can put together a new capability, plug and play, and create capabilities that had never been done before using the system that we are developing internally. But it's not just us. I mean, the idea, and actually many of the demos we do, we are actually using other community members, their capability. So it's not everything that we are doing in those demonstrations is not all done by Pacific defense companies, but it's the community that's built around CMOS SOSA that helps us. We are leveraging the entire community to be able to do those demos. I mean, that should be a key point to understand is, we are standing as a very famous physicist once said, we are standing on the shoulders of other giants to create those capabilities. So from the software side, just to give you a quick overview, I mean, so basically what we do is we have the MORA defined MORA software defined radio that's producing RF data stream spectral snapshots that comes into the SOSA modules that's allowing me to do distribute streaming, do a control of the radio, processing of the data, storing of the data. We're not talking about system manager here, but we also have a system manager that allows you to manage the system. But the task manager is working with other modules for doing signal classification, ML tool, AI/ML techniques, and then third-party systems like photons, Scepter, CFE, and also interacts with the outside C2 elements like EWPMT, Raptor X, and WinTAC. We support it's a message broker architecture, so we can support ISA, OMS, OCI, and SOSA is basically defines something called the host platform interface. That's basically a translation layer from the SOSA messaging to a third-party application like OMS, GICD, Kafka, microservices interaction. So how do I connect that to what's going on in the world? I said that there's a good story here. The good news is that the DoD, or at least the Army, has embraced this concept, and what that's doing is that they're already creating what large companies, like automotive industry or HP in high performance computing industry has already done, or the printer industry has done, is to be able to create product families. That's a group of related programs or products that's derived from a product platform, where product platform is defined as components that's with a sufficient variety in the marketplace to maintain economy of scale within their manufacturing and production process, thus reducing cost and enabling rapid technology insertion. So if you look at in terms of product families, I mean, EWSC, when Colonel Finch was the PM for EWSC, he actually had approved a directive to use a CMOS for integration of all future EWSC system. So if you have things like program of record for MFU large, tactical cyber equipment, CC, ManPack, which is the force lot chassis that I mentioned. I'm aware of 4 to 13. So that's another company that makes that. TLS system for SIG and EW cyber enabling integration. These are all program of record that are leveraging CMOS technologies. There is a CMOS mounted form factor, and this thing needs to be updated. I just took a snapshot of a chart I had, but that's also become a program of record. I will talk about that in a little bit. AKIT, and there are a lot of prototype efforts. So there's a product family starting to emerge around a product platform based on CMOS SOSA. So this concept that once you control something like a CMOS, which is open architecture, that allows you to create a diverse ecosystem of producers of technology that creates diversity and competition in your system is already happening around CMOS SOSA, which is different than a lot of other standards that have happened in the past. So you're actually starting to see that emergent behavior that I was talking about in my initial charts. So Jason. I'm quoting you, so if I get this wrong, please forgive me. So Jason actually gave an interview recently, and he was quoted in this magazine. Due to modularity, CMOS enables cost saving through greater competition during acquisition phase, but there's also potential for significant cost saving over the entire life cycle, including sustainment. I mean, part of the thing you have to remember is now that you have common parts, I mean, it actually makes your depot cost much lower. Your keeping an inventory of parts to do maintenance, all that cost is coming down when you have standardization of parts. I mean, that's one of the things that the automotive industry learned back in the 90s, which revolutionized the automotive industry. But the stuff we are talking about here is not something that's new. I mean, these kind of revolutions that are seismic change has happened in the commercial industry over the last 30 years quite dramatically, and the companies that haven't managed to do that, they are either dying or have died. And I work for some of those companies. So just recently seen in the wild, I was at the FACE TIM 2 weeks ago, and there were charts that C5ISR was showing a system that is what's called the CMFF prototype system, our A-kit for vehicles that integrates maps, MMC software, which generally runs on MFOS, and ManPack radio to a TSM CMOS card, running the MMC software on the SBC, and AP&T card, all from different vendors, all running in a CMOS chassis that you see on the table here. Multiple members of the CMOS community produced the different systems, and it was integrated by C5SR and demonstrated the capability at FACE at TIM. And then Air Force had another booth where they were showing integration of, again, CMOS host SOSA aligned hardware, integrating through OMS MORA adapter, the gateway we talked about, to show a radar-like application, and integrating that through a FACE interface to a FACE-supported display, right? To do C2 from OMS system all the way to CMOS host hardware sensor. So again, CMOS SOSA is driving this revolution to be able to create this multifunction RF system to support multi-domain spectrum operation, and that is happening as we speak. It's not a proposition that it was in 2014. So you saw this chart before. This is the CMOS mounted form factor, CMFF. It's an Army program of record at this point. Mission Command is producing the Universal A-Kit, as it's called, to provide the platform with one or more standard chassis that are plumbed for power, network, and radio frequency distribution. The CMF prototype minimizes the need for platform-specific integration. You actually have an A-Kit that can go onto a platform without any need for any additional capability and mounts. It's the rapid technology insertion that you can do now. I mean, you can take the A-Kit and you can add a EWSDR card, and you have an EW sign-in system. You can add multiple TSM card, and you can do robust counts capability. But it's starting to do building blocks. I mean, that little neck of the bow tie, you're starting to control that neck of the bow tie and allow innovation to happen by community. So here's another example of ecosystem to create interoperability for tactical radios. All of these things that are shown over here are either programs being funded, already been developed, like the TSM card is in the A kit today. The different TIMs 4, 5, 6 are funding so many of the other capabilities. We have actually worked with some of the software ecosystem that works around the different waveforms to actually create tactical radios to be able to create conference calls using the CMOS systems, provide failover capabilities using the Cisco 8000 router, connect that to the WinTAC, ATAC ecosystem, support the MMC software that gives you connection to the mission command to be able to reprogram system over the lower tactical network. So ecosystems are starting to develop around different communities of interest, but the key thing to remember is that this is a common building block built on top of CMOS Motor Victory data bus. Right? So what does it all mean? I mean, yeah, it really means, I mean, we can actually reduce system size, weight, power, and cooling, because now we can take things like crew system, EW system, resilient comm system, the AP&T box, processing capability for doing things like mission command software, Cisco tier router, Redcom, and others. But these are just the things that I'm aware of, and I've had my fingerprints on it. That can all be done on a CMOS based system and connected through common UI devices like a MFOS display or a WinTAC, ATAC display, or using just a simple, straightforward laptop, prioritized laptop to connect. So CMOS is that the set of standards that we started our discussion with, that talks about how, what are the standards that you can build an entire ecosystem community of interest that can support the changing needs of the end users, and you can create new capabilities very quickly because now you're using existing Lego blocks to create new capabilities. So back to a little advertising again, in a sense, but it's to make the point. What we have been doing this year, starting Q1, I mean, not being, so not being able to go talk to customers during COVID and all that, so we had to come up with another way to get our story out. So what we started doing is that we started doing this quarterly demo, and we did do it on through Teams, or we have used Teams, the government Teams capability. And we did the first time, we did basically how do we on a single CMOS box, how do we do a converge EW SIGINT comp type mission. Then in Q2, the idea was that now that we have converged capability, I mean, how do we support different MOSs to be able to support the workflow for S2, S3, and S6, and we showed a lot of that capability. And Q3, Q4, we're going to continue that kind of work, and start bringing in some of the sphere capabilities to do more complex EW environment, working with other third parties like Cisco and other companies to bring in more smart routing type capability, and showing new cards like SingGuards and the ability to do TSM SingGuard bridging, start to bring in some of the Perceptronics cognitive EW to be able to go against agile threats. So it's combining the work being done at Sphere Research and Perceptronic to actually to go from agile to go after agile threat using cognitive EW. So steadily, you're moving, from CMOS is real to a true mission system. It's not just a CMOS is a bunch of cards and backplanes and chassis, but we can actually start to put together these different capabilities that is being produced by the CMOS SOSA community, and start creating a true mission system that's from end to end based on standards, so you can actually take out any component from hardware to software and plug in another capability from another vendor and create new capabilities very quickly without having to go back to system engineering and redesign the system. So, for CMOS, if you look at the CMOS Consortium, I think 97 is an old number. They're actually over 100 now. I should update this chart. There's a large community of developers that are developing hardware and associated software that they need to do the work. There are primes that are starting to support programs based on CMOS systems. We're not quite the Apple supply chain yet, but it's growing very fast. I mean, every time I go to one of these trade shows and things like that, there's always new faces and new company names that I had not heard of, and all of a sudden, they're there doing CMOS SOSA work. So, quick lessons learned. I mean, from our own experience, I mean, adoption of CMOS SOSA aligned modules allowed us to development of CMOS system demos in less than 2 months from planning to execution. Adding new capabilities or updating is measured in days and weeks rather than months. We observed a lower development cost, risk, and time. Adapting SOSA architecture has allowed us to start supporting product family development even within our own company. So this commonality and reuse of these components across multiple programs that we are supporting, and I think by inference, what I'm implying is, what the government will be able to do across the multiple programs by having commonality of components will reduce to cost saving and rapid innovation, as it has. We are a case study in that. So this is personally what my current view of CMOS SOSA status is. The CMOS SOSA standard, as we talked about, is maturing with a growing vendor base. We have the software, hardware software integration well defined and in process of multiple programs today. The key thing to remember is, I mean, every component has to have that standard base. I mean, what the government program PMs will have to make sure it doesn't happen is, at some layer, the multiple layers that I had talked about, if one layer in that thing is proprietary, then that makes it very hard to do plug and play. I mean, every layer, so now you have to test the entire system to make sure by taking one component out and plugging another one in, how does that affect the proprietary layer? Did that break or not? So it just adds to complexity of the system. But if every layer is, the entire system is based on standards and well-defined interfaces, then that supports the premise of cost reduction and innovation, speed of innovation. Every time I turn around, there's a new competition. I mean, personally, I think from the community, that's a really good thing. I mean, but obviously, as somebody getting a paycheck based on these things, every time there's a competition, it just another section of my hair goes grayer. So continued effort to flourish the ecosystem. What the community needs to do is to start requiring standard-based MOSA, start naming, what standards needs to be in the program to drive component competition into the acquisition process. Program of record should document hardware, software, open architecture design requirement for the entire program development effort, not just during the technology maturation phase, but all through. So if I have a TSM card in a system that's shown in the picture over here, at any phase of the system, I should be able to take a TSM card out and put another CMOS TSM card in without having to worry about it if it came from the same vendor that everything was tested during the initial phase, the technology development phase of the program or not. So that is the gist of my presentation. Hopefully it was informative and fun for you all. I didn't tell any jokes, so I don't know how much fun it was, but hopefully it was informative. Open to questions?
Thank you, Niraj. I appreciate your presentation. It was very informative. Do we have any questions at this time? Well, I think it looks like your presentation was very informative, so informative that there's no questions. So like I mentioned, what we're going to do is I'm going to send out a copy of the slides that Niraj presented today. And I'll also be taking the recording of his presentation, and I will send it via Teams, so you'll be able to see it, but we'll also be uploading it to YouTube. So we'll send you that link as well in the next couple of days.
Mary, and one thing, my contact is on the slide. So if you guys are anybody's interested in being invited to our quarterly demos, send me an email. I will add you to the distribution list.
Terrific. And I'm going to shamelessly ask, like I do every month, if anyone has a topic that they would like to see a presentation on, or if somebody would like to give a presentation or volunteer someone else to give a presentation, I would appreciate that. Like I said, every month we try to bring something that's going to be of interest and value to the community at large. So if you have any thoughts, please reach out to me and let me know. All right, so at this time, I'm going to stop the recording, and I'm going to thank everybody for having participated.